Okay. Good evening. Can you hear me? Can you hear me? Good evening. Okay. Good. Hi. Okay. Last Sunday, we discussed about heat expansion or thermal expansion. How many types of thermal expansion? According to the material type, there are three types. What are types? Solid expansion, liquid expansion, and gas expansion. Okay, that means all materials, all substance are what happened? Expanding due to temperature, increase the size of material, right? Increase the size of this material. Now, we discussed solid expansion. This is a summary of last Sunday lesson. We discussed about expansion, thermal expansion. According to material type, it is three types, right? Three types: solid expansion, liquid expansion, and gas expansion. Solid expansion, again, three types. What are the types? That's a summary of last week lesson. Solid expansion, three types. What are the types? Linear expansion, area expansion, linear expansion, area expansion, and volume expansion. It's mainly three types. If you got liquid and gas both has only volume expansion. Liquid and gas both has only volume expansion. Okay, that's a full summary of the expansion lesson. All right. Now let's move into our refresh number. Before that, how about the today date? Today, 17th of March. 17th of March. Forget about this month. After this month, you have April. April with New Year break, you will have only limited time for working. Then May, June, July. Only 120 days. 120 days. This is the April, May. So this is March. You have very limited time now. Therefore, as I explained last week, the time management. Nowadays, the limited time, the remain limited time, the time management is very, very important. You should have prepare your own plan and work according to this. Balancing all three subjects, that is very important this time. Balance all three subjects and working consistently. Every day working, very important. This is April, March, June, and July. Only 4 months. 4 months mean 120 days. 120 days. Actually, with New Year break and everything, you have averagely remain only 100 days. Averagely. Therefore, this final 110 days, very carefully you have to manage into three subjects and complete work maximum in three subjects. It's very important to get your good result and good rank. Okay. Okay, this is exam. Oh, sorry. That was an exam question. Okay. Let's come to the question. Write the relationship between real and apparent expansion of a liquid placed inside the vessel. Liquid placed inside the vessel, real and apparent expansion. Okay. Last week we only discussed about solid expansion, but in the question asked about liquid expansion. Okay, liquid. I told liquid and gas both has only volume expansion, no linear or area expansion, because we can't measure. We can't measure. Therefore, we only think gas and liquid both. Gas and liquid commonly we called as fluids. Fluid. Solid is not a fluid. Do you remember? Do you know what's the definition of fluids? One of the fluids can fluids. What's the meaning of fluid? What's the definition or how we define a fluid? How we define a fluid? How we can define a fluid? Fluid. Anyone? Tanya? How we can define the fluid? Fluid එකක් කියන්නේ? Fluid අපි තරලයක් කියන්නේ? Fluid තරල. What's the definition of fluids? Normally liquids and gas are both fluids. Both fluids. Both fluid. Very good. Any material, any substance able to flow, or that in other words we can say the any substance with viscosity. Viscosity means the flowing ability. Flowing ability. Any substance with viscosity that we call as fluids. Fluids. In fluid mechanism, we can discuss again. They are the fluids, liquid and gas. Remember, liquid and gas both has what? Only volume expansion. Only volume expansion. Okay. That's a liquid expansion. Liquid expansion. Liquid expansion. Liquid expansion. Okay. You can get this type container that we call as a flask. Flask. I think it is a round bottom flask. Round bottom flask. And you can fill colored water up to this level. You can fill blue color colored water into this level. Into this level. Blue color colored water. Colored water. Okay, I have filled up to this level. Think the initial liquid level is point A. The initial liquid level A. Point A. Okay, now if it is using Bunsen burner or whatever heating method, if we heat this container, if we heat this vessel, what happened to the liquid level? It is increasing. Initially, it is increasing or decreasing. The going up or going down, what do you think? Initially, yeah, in the class we discussed. Initially, the liquid level going up, going down, or going up. Quickly. What do you think? The liquid level going up or going down? Yes, initially going down. What is the reason? You know, first of all, the heat absorbed by container. The heat absorbed by container, heat is a solid. Now what happened? The solid start to expand. Solid start to expand. Give me a second. Give me 1 minute. Okay, sorry. Okay, first of all, what happened? The provide heat energy absorbed by container. Then what happened? The first initially the vessel, the container start to expand. In the expansion of the container, the liquid level gradually decreasing. The liquid level gradually decreasing initially. Think initially it's decreased up to this B point. Initially decreasing up to B point. B point. Now after absorb this heat energy, after absorb this heat energy by container, the container absorb heat energy transfer to the liquid. Container absorb heat energy transfer to the liquid. Then what happened? The liquid start to expand. You know, the in solids, more than liquid, solids, liquid can expand because molecules, solid molecules are combined to each other with strong bonds. But comparatively, liquid molecules are loose. They're not strongly combined, right? Therefore, more than solid expansion, liquid is expanded up to this level. From this level to increase this level. Okay, think that is a C level. This is a final liquid level. This is a final liquid level. Okay, what happened first? heat energy absorbed by container, start the expansion of the vessel container, then decrease the volume of the liquid, actually not decreasing, decrease the level of the liquid, decrease the level because increase the size of the container, decrease the level of the liquid, then liquid absorb heat transfer to the solid absorb, the container absorb heat transfer to the liquid. In this case, what happened? In this case, what happened? It is increased up to higher point. The liquid level increase up to a higher point. Okay, now what is the actual liquid expansion? What is the actual liquid expansion? Is it normally the apparent, the visible increasing? This is the initial level. After some time, this is the liquid level. Normally, this difference that we call volume difference, we called as apparent expansion. Apparent expansion. Apparent expansion. The visible volume change. The visible volume change that we called as apparent expansion. Apparent expansion. Apparent expansion. Okay, what is the meaning of this level? What is this? This is decrease. This liquid level, water level decrease due to what? Due to contain expansion. This is a contain expansion. This is a contain expansion. This is a contain expansion. If you want to get real expansion or true expansion, how to get the true expansion now? True expansion, true or real expansion. Real expansion. What is the equation? The summation of both apparent expansion plus container expansion. Apparent expansion plus apparent expansion plus container expansion. That's a theory of liquid expansion. Gas also same, container expansion. That's the basic theory of the liquid expansion. Okay, if you need to note down anything, you can note down. Okay, actually this is the answer. Okay, for first part, write down the relationship between real and apparent expansion of a liquid placed inside the vessel. What is the answer? The real expansion equal apparent expansion plus vessel expansion. Apparent expansion plus vessel or container expansion. Apparent expansion is A. Apparent expansion plus vessel expansion. Okay, this is the answer for first part. This is the answer for first part. This is the answer for first part. Next one. If the vessel is filled with liquid of volume V and the temperature of this system is increased by theta, delta theta, then okay. If a vessel is filled with liquid of volume V and temperature of this system is increased by delta theta, then the apparent expansion VA and real expansion VR of the liquid are given by VA equal that in apparent expansion VA equal V gamma delta theta. V gamma delta theta, and real expansion given V delta R delta theta. Sorry, V gamma R delta theta respectively, where gamma A and gamma R are coefficients of apparent and real volume expansions respectively. Good question. Okay, first part 1. A volume of 120 square centimeter form a liquid with coefficient of real volume expansion. The real volume expansion given. The real volume expansion given. It's a very good question. Real volume expansion given 10 to the power minus a volume of 120 cubic centimeter from liquid with coefficient of real volume expansion 2 into 10 to the power minus 1 Celsius is fitted into a uniform cylindrical metallic vessel having a coefficient of linear expansion 2 into 10 to the power minus 5 per Celsius. Calculate the real expansion and the apparent expansion of liquid when the temperature of the system increase from 30 Celsius to 60 Celsius. It's very simple. The equations given above. The real volume expansion and apparent volume expansion equations given. Then you can copy these equations. It's very simple. The apparent volume expansion. First, you can calculate the apparent volume expansion. The first one. No, second one. The VA, the apparent volume expansion equal. What's the equation? Our normal volume expansion equation. Last week I explained. What is our delta V equation? Delta V equal V1 gamma delta theta. The same equation. VA, that in apparent volume expansion equal V gamma apparent volume expansion coefficient. Okay, apparent volume expansion coefficient multiplied by delta T. Delta T means temperature difference. Now, the question, the real expansion and the apparent volume expansion. Calculate the real and apparent expansion of the liquid when the temperature of the increase from 30 Celsius to 60 Celsius. Okay, first of all, you can calculate the real volume expansion. No, the real volume expansion coefficient is given. The coefficient of real volume expansion. Then I will change into real volume expansion. Real volume expansion. Real volume expansion. We are. Okay. Now, how about the initial volume? 120 cubic centimeter. 120 cubic centimeter. The real volume expansion coefficient 2 into 10 to the power minus 4. 2 into 10 to the power minus 4 per Celsius. Per Celsius. How about the temperature difference? Temperature difference 30 Celsius. 30 Celsius. Now Celsius to per Celsius cancel out. You can get the value. Could you get this value in home? 120 into 2, it is 120 into 6, 740. Isn't it? No. The volume expansion coefficient given. Volume expansion coefficient. Coefficient of volume expansion. Real volume. It's a volume. We are calculating real volume expansion dot. The volume expansion given. Make a mangatte. This value you don't need to multiply by 3. Don't misunderstand. Understood? It's volume expansion coefficient. Why volume expansion coefficient in gamma? Why you need to multiply by 3? Yes. Hurry. Can you send me? Can you send this value? Uh, 120 into 2 into 30. 7,200. 7,200 into 10 to the power minus 4. 0.72, right? 0.72. 0.72 cubic centimeter. Am I correct? Dehini? I got this. Hurry. Now the problem. Now the problem. Now the real volume expansion. Okay. The real volume expansion. This is a real volume expansion. 0.72 cubic centimeter is the real volume expansion. But the question asks real expansion as well as apparent expansion. How to calculate apparent expansion coefficient is not given. And we don't know the volume enhancement, the volume increase amount we don't know. But you can calculate, Balanda, but you can calculate the container expansion. See, the metallic vessel have the coefficient of linear expansion given. Now you can calculate the container expansion. container expansion, container volume expansion. I can say the container volume expansion VC, it's V into gamma C into delta theta. That's my new equation. The container volume expansion. V1 gamma delta theta, our common equation. Okay. Now, the volume, what is the volume of the container? What's the volume of the container? It's filled into a uniform cylindrical, completely filled. Then the volume of the container equal to the liquid of volume, 120 cubic centimeter. Now, Joel, now you have your point is correct. Now I want the container vessel material volume expansion coefficient, but it is given linear expansion coefficient. You have to multiply by 3 to convert into linear expansion into volume expansion. Now the value 2 into 10 to the power minus 5, 2 into 10 to the power minus 5, but you have to convert into 6 into 10 to the power minus 5 per Celsius. The temperature difference 30 Celsius. Now Celsius to per Celsius cancel out. I need this value. 120 into 6 into 30. You all understood? $21,600. 21,600 into 21,000 multiplied by 10 to the power minus 5. 1, 2, 3, 4, 5. 0.216. 0.216. 216 cubic centimeter. This is a container volume expansion. Container volume expansion. Now you already know container volume expansion as well as real volume expansion. Then you can calculate the apparent volume expansion very simply. What's the equation? What's the equation? Sorry, the real volume expansion equal VR. VR, I am writing by symbols. VR equal to VA plus apparent volume expansion plus container volume expansion, VC. VC means container volume expansion. Now you already know the real volume expansion 0.72. 0.72 equal to apparent volume expansion, we don't know, VA plus container volume expansion 0.216. 0.216. Now VA equal, you can isolate the VA, the volume, apparent volume expansion. It is 0.72 minus 0.216. Can you send me quickly? Fatima? Yes, 0.504. 0.504 cubic centimeter. Okay, this is the apparent volume expansion. See, the same theory. Theory ekama hala tiyenne, but in a different form. That was an exam question. Please note down clearly. Who correct this entire part? Who got this apparent and real and apparent both correctly? Raise hand. Kawda hari? Dini? Kabir? Harida. Fatima? Okay, very good. Did you get it? Okay, very good. Fatima? Good. If the area of the bottom of the vessel is 12 square centimeter at 30 Celsius, calculate the height of the liquid in the cylindrical vessel at 60 Celsius. 60 Celsius. It's a good question. If the area of the bottom of the vessel is 12 square centimeter at 30 Celsius. Yes. The area of the bottom given. The bottom area given. It's 12 square centimeter at 30 Celsius. Initial temperature. Calculate the height of the liquid. Actually, it is related to volume, right? Calculate the height of the liquid in the cylindrical vessel at 60 Celsius. Okay. Third part. Now it's a cylindrical vessel. Cylindrical vessel. Cylindrical vessel. Cylindrical vessel. The base cross section area given. The cross section area of the base 12 square centimeter. 12 square centimeter. If it is 12 square centimeter, can you tell me what is the height of this? At 30 Celsius, it is 12. Can you tell me what is the height of this container? What is the H at 30 Celsius? What's the H? At 30 Celsius. The basic thing, the area volume. It is not the heat lesson. At 30 Celsius, don't think about temperature increasing or whatever thing. Joel, at 30 Celsius, the base cross section area of the cylinder given 2 square centimeter, and the previous part given the entire volume of the cylinder 120 square centimeter. Then what is H at 30 Celsius? What is H at 30 Celsius? It's 10. Do we need to calculate? No, I mean the volume of any cylinder equal to it is a uniform cross section object. Cross section area multiplied by height. It's 10. 10 into 12, 120. But it is in 30 Celsius. It is in 30 Celsius. But now it is asking about may at 60 Celsius. At 60 Celsius. Now the temperature increasing by 30 Celsius. Temperature increasing by 30 Celsius. Then what happened? The volume, the container volume increased by our previous part. The container volume increased by 0.216 volume, right? 0.216 cubic centimeter. 216 cubic centimeter. Then how about the container volume? at 60 Celsius. Yeah, container volume increase in there further. The volume increased to 120.216 cubic centimeter. Now the cross section area not changing, it's 12 square centimeter. Now the height is asking. Very simple. Very simple. The 120, the volume 120.216 equal 12 into H. Now H equal 120.216 over 12. It's a very small value decreasing because due to container expansion. Due to container expansion. Due to container expansion. I told initially the liquid level decreasing, right? Initially it is decreasing. 120.216 divided by 12. So, the real expansion actually liquid then 0.72. Yeah, it's increasing. 10 point H equal 10.018 centimeters. 10.018. That means final Mahan, final. Okay, next one. Okay, calculate the amount of heat required. That means the quantity of heat. Calculate the amount of heat requirement to increase the temperature of system from 30 Celsius to 60 Celsius. Consider the heat capacity of the vessel 400 joules per second and the density and the specific heat capacity of the liquid as 1200 and 4000 J kg minus 1 per Celsius respectively. Okay, the quantity of heat, very important. This is a very good question, very good rational question, right? Question number 4, part 4. Okay, Q equal the amount of heat absorbed, it is equal to container absorbed heat and container absorbed heat container absorbed heat plus water absorbed heat. Okay, for container the heat capacity is given. For container the heat capacity of container given. Then what is the equation? C theta is the equation. C theta plus water absorbed heat, the specific heat capacity of water given. It is mc theta. That's the method. Now it's only increasing from 30 to 60 Celsius. No any physical state changes. Therefore, specific latent heat don't need. Specific latent heat don't need. Okay, how about the container's heat capacity? Container heat capacity 400 joules per second. Sorry, 400 joules per Celsius. 400 J Celsius minus 1 into 30 Celsius. 30 Celsius. This is a container absorbed heat. Okay, before calculate water absorbed heat, we have to calculate the mass of the water. Okay, can you calculate the mass of the, it is not water, liquid, mass of the liquid? The mass of the liquid, the specific heat capacity is given 4000 and the density is given, you know, the density of liquid equal to the mass over volume. Mass over volume. The density is given 1200 J kgm minus 3 equal m over, what is the volume? What's the volume of liquid? What's the volume of liquid? Fatima? How about the volume of liquid? Kedan Tihini? Real volume or initial volume? Kedan Khabir? What's the volume? Initial, yes. Because we heating 120 cubic centimeters, the volume changes, doesn't matter. Just heating, okay. Just heating 120 cubic centimeters. No? Cubic centimeters. Now you have to convert to cubic meters. It's another problem. How you convert cubic centimeters into cubic meter? Because the density given 1200 J kg minus 3, that means kilograms per cubic meter. Kilograms per cubic meter. Now how to convert cubic centimeters into cubic meter? Then we can cancel out. Cancel karan pula. Then we can cancel. Give me a second. Okay, now the problem, how cubic centimeters convert into cubic meter. That's a problem. Amina, how convert cubic centimeters into cubic meters? Okay, how convert centimeters into meters? Divide by 100, right? Now cubic centimeters divide by 100 into 100 into 100. Cubic. Okay, this is a mass. This is a mass of water. The mass equal cross multiplication 1200 into 120 divide by 100 into 100 into 100. Now 30 to 30 cancel out. 12 into 12, 144. Divide by 100. Then it is very small amount. 1.44 kilogram. 1.44 kilogram. Very important questions today we are doing. Okay, 1.44 kilogram. Specific heat capacity 2000. It's given 2000. Oh no, sorry, 4000. No, 4000. 4000. Sorry, 4000. 4000. J kg minus 1, k minus 1 into temperature difference, same. Three zeros remaining. Yeah, wait. Yeah. Yes, good. Then it is 1000. 1000, sorry. I can't write. 144 divide by 1000. Then 0.14. 0.144. 0.144 kilogram into 4000 into temperature difference 30 Celsius. It's Celsius. Celsius to Celsius cancel out. Celsius to Celsius minus 1 cancel out. Okay, then calculate. 4 into 3, it is. Clearly note down these calculations because they are exam type questions. They are exam questions. Okay, 4 into 3, 12. 12,000 joules plus 144 into 4 because 30 to 3 decimal point cancel out. 144 multiplied by 144 multiplied by 4 multiplied by 30. It is 17,280 joules. Then the final total amount of heat absorbed 12,000 at 12,000 29,280 joules. Very important questions. Any doubt up to now? Clearly note down these calculations. They are very important. Who could get this answer? How to make a hurry? Fatima? Correct. Dini, correct. Tanya, good. Fatima, Habib, whatever. It's very simple. First, I got the contain absorb heat, all details given. Then I got the water absorb heat. Only difficult point is calculate the mass. Mass calculation only the task. Others are simple. Good. Let's move into next part. Next one is the electricity one. Electricity completely discussed, no? A heating coil rated as 230 voltage. 230 voltage. 230 voltage means supply voltage and output power 1 kilowatt. 1 kilowatt means 1000 watt is used to heat the system. This is supply power. Supply power. Assuming that there is no heat and exchange with environment, that means no heat lost. No heat lost. Calculate the required time required to increase the temperature of the system from 30 Celsius to 60 Celsius. Very simple. Now, how much heat required? 29,280 joules required. One next page. Okay, the heat requirement, clearly note down, heat requirement 29,280 joules. And according to question, the heating coil rated 230 volt and 1 kilowatt is supplied. 1 kilowatt mean what is the meaning? 1000 watt. 1000 watt. 1000 watt. Supply 1000 watt. 1000 watt. Actually, what is the meaning of this 1000 watt? 1000 watt mean actually 1000 watt means 1000 joules per second. 1000 joules per second. If it is 1000 joules per second, 1000 joules per second, 1000 joules per second, per do you remember now using equation or simple method you can calculate? Do you remember we have equation the energy equal PT, P equal VI and energy equal PT. Now the question is time requirement. Time requirement, sorry, T. Time requirement. Okay, the energy amount 29,280 equal the power 1000. The power 1000, time we don't know. Time done. Then time equal 29,280 divided by 1000. 0 to 0 cancel out. Time 29.28. seconds. Very rapid heating process because very small amount, 0. Gram guide and 0. How about the mass? 0.1 phone. Again, very small amount. Very small amount. Very small amount. Approximate 30 seconds, it will heat it up to 60 seconds. 60 seconds. Okay, if not, without the equation, you can calculate that. Without the equation, we can calculate that 1000 joules per second. That means per second 1000 joules. If not 1000 joules, supply within 1 second. Then 29,800, 29,208, sorry, 29,208 joules. How many seconds required? How many seconds required? 29,280 divided by 1000. 29.28 seconds. Okay, any method, both correct. Understood? Okay, how about this question? That was exam question. What do you think about this question? It's a good question, right? Most possible to ask this type rational questions in your paper as well. Normally heat and electricity questions little bit rational questions always. Therefore, you have to more practice, and work on more heat and electricity questions, and you have to more focus into this area. Okay, that's why I discussed all type of questions in the electricity, and from today I will explain all types of advanced question in heat lessons as well. Heat lessons as well. MCQ. 18 gram of coconut oil gas. Coconut oil gas at 950 Celsius. Sorry, it is not 950. Printing mistake. It should be make it is 95 Celsius. May 0 එක 95 Celsius should be converted into solid at 10 Celsius. Please correct this. 10 Celsius. The melting point and the boiling point of the coconut oil are 15 Celsius and 80 Celsius. Calculate the release amount of heat to the environment. The specific heat 100 J kg minus 1 K minus 1. The specific heat, the latent heat of coconut oil at melting point and evaporation, it is given J kg minus 1, J kg minus 1 respectively. Okay, now you can calculate. I think now the answer is come. 18 gram of coconut oil, gas. Initially it is a gas. (95 Celsius) should be converted into solid at 10 Celsius. Initially, it is a gas, okay? The melting point and the boiling point of the coconut oil are 15 Celsius and 80 Celsius. calculate the release amount of heat to the environment. That means always in cooling process. Okay, it's a cooling process, always heat released to the environment. That's how it is cooling. The exothermic process, gas convert into solid, Okay, can you send me answer? Can you send me answer? Done, but gas convert into solid. It's a long process. Let's see. Okay, do you remember in heat lesson we discussed about thermal curves? Okay, before start, it's a graphical representation. It's a graphical representation of temperature change with time. Okay, the x-axis is always time. If you don't remember, please note down. The x-axis is the time. The y-axis is always temperature. It's temperature and time. Okay, initially, where it is starting? 95 Celsius. 95 Celsius. Okay, 95 Celsius, it's solid. This is the 95 Celsius because it's a temperature column. 95 Celsius. 95 Celsius. And what is a boiling point? 80 Celsius. This is 80 Celsius. And this is a 0. This is a 0. And this is the melting point. It is 15 Celsius. And this is a 10 Celsius. Okay, that's the journey. Okay. It has a specific, this journey, it's passed two specific points, melting and boiling points. Okay, they are the specific points. At 0 Celsius, at 0 second, initial point, starting from 95 Celsius, 95 Celsius solids, 95 Celsius solids, Mabel, 95 Celsius solid. Now, gradually temperature decrease up to 80 Celsius. 80 Celsius. In 80 Celsius, take some time and convert into what? In 80 Celsius, take some time and convert into liquid. After completely converting to liquids, it's gradually convert into solid like this. Solid. Sorry. After completely converting to liquid at 80 Celsius, it's gradually convert into 15 Celsius liquids. Temperature without state change. But at the melting point, or that we call as freezing point in this case, because it is opposite direction, freezing point, it's convert into 10 Celsius solid. 10 Celsius solid. Okay, that's the journey actual. Okay, this is a journey. Okay. Okay, this is the thermal curve. If you want, I will explain about the initial point is a 95 Celsius. If you want, you can note down this. This is a thermal curve for this process. The 95 Celsius solids, coconut oil solids. Sorry, gas. 95 Celsius gas, sorry. This is 80 Celsius gas. 80 Celsius gas. This is 80 Celsius liquid. 80 Celsius liquid. 80 Celsius liquid. This point is the 15 Celsius liquid. 80 Celsius liquid gradually convert into 15 Celsius liquid. The 15 Celsius liquid convert into 15 Celsius solid. Finally, it is converted into 10 Celsius solid. Temperature drop solids. Okay, this is a thermal curve, but the question asks the heat releasing amount, the releasing heat amount. Okay, first before question, you can note down this thermal curve. The thermal curve also always asking in the exam. Thermal curve. Okay, the thermal curve is what's the definition? It's a graphical representation about the relationship between time with the temperature change of any case. It's a graphical representation between time and the temperature of any case. In this question asks how much heat released to the environment during this process. During this process, how much heat released to the environment. Okay, how to calculate that? Okay, first of all, you can write down the process. You should have idea what is the process. Now, initially 95 Celsius gas convert into boiling point gas, 80 Celsius gas. 80 Celsius gas convert into 80 Celsius without temperature change liquid, because it is cooling process. And the cooling process 80 Celsius liquid convert into 15 Celsius liquid. 15 Celsius liquid convert into 15 Celsius solid. 15 Celsius solid convert into 10 Celsius solid. That's a store. That's a jar. Now the question asking in the Q, the amount of heat release, Q equal for temperature difference, mc theta. No temperature difference, physical state change, ml, plus temperature difference, mc theta. Physical state change, ml, mc theta, final. Understood? Her. Go to the question. How about the mass, Q? How about the mass? 18 gram. 18 gram. 18 gram. But other all data given by kilogram, we have to convert 18 into kilogram. 18 divided by 1000. Specific heat capacity 100. 100. 100. Temperature difference 95 to 80, 15. 15 plus 18 over 1000. Latent, specific latent heat at evaporation. Actually, it is not evaporation, that's called as condensation, right? I think you can remember physical state change names. Physical state change, condensation, gas convert into liquid, but specific latent heat common for condensation and evaporation both. It is 990. 990 plus 18 over 1000. Specific heat capacity 100. Temperature difference 80 to 15, it is 65. 65. M 18 over 1000. Specific latent heat at melting 360, but is now freezing, but same way. 18 over 1000. 100 into temperature difference 5. Now you can get the answer. 2020 cancel out. 18 into 50. 18 into 50. Would you get the answer? 18 into 50. 270, 27. Because 0 cancel out. 0 to 0 cancel out. 18 into 99. 17.82 plus 2020 cancel out. 18 into 65. 117 plus 10 to 10 cancel out. 36 into 80. 6.48 plus 2020 cancel out. 18 into 5. 9. Now you can add these values. Add those values. 27 plus 17.82 plus 117 0.2 plus 9. 117.24 joules. Yeah, this is the final answer. 117.42. I don't have answer. Yeah, I think it's mistake. Yeah, it's a question error. 117 point, note down the answer. 117 point, not 117, no? Mistake. Wait. But summation value. Sorry, my mistake. One hundred 177.24. 177.24. Yeah, this is the answer, but it is not kilojoules, it is joules. Approximately this is the answer. 170.4. Okay. Question number 3. That you can calculate. Can you send me value? Answer. They increase the length of 2-meter long steel rod when the temperature rises from 300 Kelvin to 310 Kelvin. The linear expansion coefficient of the steel is 1.2 into 10 to the power minus 4 per Kelvin. Hi. The length increase amount is asking. The increase in the length of 2-meter long. Okay, what is actually equation of linear expansion? Delta L equal, very simple. L1 alpha delta theta. Delta L asking L1 2 meters, alpha 1.2 into 10 to the power minus 4, 1.4, 1.2 into 10 to the power minus 4, temperature difference 10. 1.2 into 10, 12, 12 into 2, 24, 24 into 10 to the power minus 4. Meters. But answers given in millimeters. You have to careful. You have to careful. If you convert into millimeters, multiply by 1000, then 24 into 10 to the power minus 1 millimeter. But don't have 24 answers. You can make a 2.4 karamo. If you got millimeters in 2.4, 2.4 into 10 to the power minus 2 divided by 10, 2 millimeter. Answer number 2. If you have any doubt, please ask me. If you understood, please let me know. Send me message. Who correct this? Right hand. Okay, Hari. . Yeah, meters to millimeters. How many millimeters per meter? Very good, Kabir. How many millimeters per meter? How many centimeters per meter? 100. Then how many millimeters? Per 1 centimeter, 10. Then per meter, 1000 millimeters. Okay, Joe. Now 2.24 into 10 to the power minus 4 is the answer. How is it? But it is meters because the initial length given in meters. Therefore, answers also come in meters. Now, if you want to convert into millimeters, you can convert this value by 1000. 1000 means 10 to the power minus 3. Now, 3 to method cancel, it is only 1. 24 into 10 to the power minus 1 millimeters. But don't have 24 answers. Then I got 2.4. 2.4 means 24 divided by 10. Then it is converted into minus 2. Understood? Okay. MCQ number 4. Which of the following statement about the heat capacity of an object is incorrect? Okay, before that, I will give you summary of heat expansion. In heat expansion, I told we have three main types, no? Linear expansion, area expansion, and volume expansion. Linear expansion, delta L equal L1 alpha delta theta. If you got area expansion, delta A equal A1 beta delta theta. If you got volume expansion, delta V equal V1 gamma delta theta. That's a summary. When expansion in a one box. Expansion in a one box. Only three statements. The alpha is the linear expansion coefficient, the beta is the area expansion coefficient, the gamma is the volume expansion coefficient. Alpha is the main value, linear expansion. Alpha into 2, it is equal to beta of any matter. Alpha into 3, it is equal to gamma of any matter. That's a summary. Now, in quantity of heat, our second part of heat lesson, we discussing about three main measurements. They are the first one, heat capacity. Heat capacity. You should have clear idea what is the meaning of these three quantities. The first one, the heat capacity. The second one, specific heat capacity. Specific heat capacity. The third one, what is this third one? The specific latent heat. Latent heat. Okay, you should have full idea what is the meaning of heat capacity, what's the meaning of specific heat capacity, and what's the meaning of specific latent heat, and what are the differences between them. Hari. Mataka, what's the meaning of heat capacity? What's the definition of heat capacity? Do you remember? Anyone? Matakaraga? Heat capacity. The amount of heat requirement, the amount of heat requirement of any object to increase the temperature by 1 Celsius or 1 Kelvin, 1 degree. The amount of heat requirement. Now, as example, think this box now temperature 30 Celsius. If I want to increase up to 31, the amount of heat requirement. The amount of heat requirement is the heat capacity of this box. That's the heat capacity. What's the meaning of specific latent heat? Sorry, specific heat capacity? The amount of heat requirement of any material to increase by 1 degree of unit mass. If you got any object, this material unit mass 1 kilogram to temperature increase by 1 degree, the requirement we call heat requirement we called as the what? Specific heat capacity. Okay, do you remember what's the meaning of specific latent heat? What's the definition of specific latent heat? That's very important. Can anyone remember? The specific latent heat definition. Heat capacity and specific heat capacity easy. The heat capacity means the amount of heat requirement to increase the temperature by 1 degree of entire object. That's the heat capacity. The specific heat capacity means the requirement of heat, the specific heat capacity means the amount of heat requirement to increase the temperature by 1 degree of unit mass. In heat capacity, the entire object. Specific heat capacity, specific means unit. Then metanath specific. What's the meaning? The unit mass. The specific latent heat mean? What's the mean? The specific latent heat, the amount of heat absorbed. Think the amount of heat absorbed or release. The amount of heat absorbed or release during a physical state change. During a physical state change without any temperature change of unit mass. Specific mean unit mass. Specific. Wrong letters. Specific. I balanda me specific definitions. The amount of heat, think it is a unit object. The amount of heat requirement to completely convert into physical state change, to completely convert into one physical state to another physical state without any temperature change of unit mass. That we called as a specific latent heat. As example, we call specific latent heat into two parts. One of the specific latent heat of melting and specific latent heat at evaporation. Sorry, vaporization. Specific latent heat at melting. Specific latent heat at vaporization. Hari, the melting means unit mass of solid material to completely convert into liquid state without any temperature change, the heat requirement we called as a specific latent heat at melting. You have to remember the specific latent heat at vaporization means what? Unit mass of liquid amount to completely convert into vapor state without any temperature change. The amount of heat requirement is specific latent heat at vaporization. Hari. Could you understand and remember? Please send me a message. Amina, can you remember all definitions? Don't by heart, try to understand what happened each topic. Yes, good. Discussing, you can find where you need to more focus. Say I am again revising. Now, which of the following statement about the heat capacity of an object is correct? The question asks about heat capacity. Before that, do you remember all physical state changes? I discussed six main physical state changes. Solid, solids, liquids and gas. Using this triangle, you can remember everything. Solid convert into liquid, what's the name? I need answers. Solid convert into liquid, what's the answer? What's the name? Without any temperature change, solid convert into liquid. What's the name, Joel? Melting, yes, melting. Melting. Liquid convert into gas. Very good, vaporization. Vaporization. Solids directly convert into gas without convert into liquid, directly gas. That we called as what? What's the name? Solids directly convert into gas without shift to liquid. Liquid directly convert into gas. Sublimation, very good. Sublimation. Sublimation. Opposite sides. Liquid convert into solids. Liquid convert into solids. Liquid convert into solids. Liquid convert into solids. Freezing, yes. Ice freezing, it. Freezing. Gas convert into liquid. Gas convert into liquid. Condensation, very good. Condensation. Gas directly convert into solid. Gas directly convert into solid. Direct. Without convert into liquid, directly convert into solid. Gas directly convert into solids. Very good. Deposit. No. Joel, what is the freezing? Previous answer. Yes, it is deposition. 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 Okay, they are the physical state triangle. Physical state triangle. Make a if you got melting, is it exothermic or endothermic? During melting process, melting means example, ice cube convert to water. Ice melting. Then is it exo or endo? Exothermic or endothermic? XO or endo? Yes, XO. And no, 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 not XO. Ice dissolve into water. එතන මොකද වෙන්නේ? කොහොමද ඒක මතක තියාගන්නේ? This is a method. Ice, in which condition ice dissolved into water? In normal outer environment. In outer environment තිබ්බම මොකද වෙන්නේ? This is ice cube. This is ice cube. It's minus temperature. Minus temperature, no? Minus temperature. But in outer temperature 32 again. What happened? The heat always transfer from higher to lower value. Then ice cube, what happened? Absorbing. It's endo. Endo. Joy. Remember, endo. Vaporization, that one also endo. Because in අපි වතුර උණු කරද්දි මොකද කරන්නේ? In water boiling, what we doing? Supply heat, then water absorb heat. Water absorb heat, endo. Sublimation also endo. We need to provide heat. Then object heat absorbing. Endothermic, endo mean endothermic. Heat released to the, heat absorbed to the material. But freezing, heat releasing. Deposition, heat releasing. Condensation, heat releasing. They are exothermic. Okay, how to remember? Understand freezing. Freezing means water convert into ice. එතන මොකද වෙන්නේ? Normally we need to place in a freezer, no? Freezer. Think it is water. Water convert normally freezing the freezer temperature minus 80. The water temperature 30. Now what happened? The temperature always transfer high to low. You understood? Therefore, heat release to the freezer. මෙයාගෙන water වලින් freeze එකට තමයි heat එක යන්නේ. Not freezer to heat. Amina, okay? Don't මේවා පටල ගන්න එපා. Oh, very simple things. Okay, this is short method. Remember this triangle and you can get all parts, all idea. Which of the following statement about the heat capacity of an object is correct? Ask. Correct. Heat capacity depends on temperature difference. What do you think? Is it correct? Heat capacity depends on temperature difference. Dini, what do you think? Heat capacity depends on temperature difference. Is it correct? Is it correct or wrong? Is it correct or wrong? Dihini? Heat capacity depends on temperature difference. Correct, correct. How we find this depend or not depend? If it is change the temperature, if we change the temperature, okay, what is the heat capacity? The amount of heat requirement to increase the temperature by 1 Celsius. 1 Celsius, no? To amount of heat requirement Q to increase the temperature by 1 Celsius. 1 Celsius. Then is it correct? Actually not correct. Why? The heat capacity depends on temperature difference. In heat capacity, we already about the temperature requirement per 1 Celsius. Only we consider per 1 Celsius. Not correct. It's wrong. Temperature difference not effective. Temperature difference not effective. Heat capacity depend on mass. Yes. When change the mass, heat capacity changing. Just that depend. The heat capacity depend on the substance. Yes. A and B on. Sorry, B and C on. Dihini. Understood? Capacity on for 1 second. Sorry, 1 Celsius. Therefore, temperature difference not effective. But mass change with the heat capacity changing. Substance type changing, the heat capacity changing. Yes. If you got a specific heat capacity, may tunama specific heat capacity Fatima, what do you think? What is the answer? Now specific heat capacity. Now specific heat capacity. Specific heat capacity. Specific heat capacity. Fatima, the specific heat capacity depend on temperature difference, correct or wrong? Tanya. Specific heat capacity depends on temperature difference, correct or wrong? Specific heat capacity depends on temperature difference, correct or wrong? Quickly, Joel. But then definition again gonna pull up. You can use definition. Sanya, the specific heat capacity. Tanya, what do you think? Correct or wrong? The specific heat capacity depends on temperature difference. No. Maybe. No. What's the heat capacity? What's the heat capacity? Heat capacity means the amount of heat requirement to increase the temperature of any object by increasing temperature by 1 Celsius. Heat capacity always calculated per 1 Celsius. Therefore, temperature difference only we consider heat requirement for 1 Celsius. Therefore, temperature difference not affecting for heat capacity. But if you got specific heat capacity, that same, the amount of heat requirement of unit mass to increase the to increase temperature by 1 Celsius. In the specific heat capacity also we consider 1 Celsius. Therefore, temperature difference is not effective. Understood or not? Habib. Yes, everyone need to work in heat lesson. වැඩ කරන්න ඕනේ heat lesson එකේ. Same as electricity. Now, specific heat capacity. Specific heat capacity depends on mass. What do you think? For heat capacity, it is correct. For specific heat capacity, for specific heat capacity, depends on mass, correct or wrong? Wrong, yes, very good. Now, in specific heat capacity, mass depend because only we consider 1 kilogram. Only we consider unit mass. For specific heat capacity, it's wrong. Specific heat capacity depends on the substance type. Yeah, it's correct. Substance type change with the change. Specific heat capacity and heat capacity. Okay, make a you have to remember this. You have to remember this. Heat capacity always depend on mass and substance type both, or material type both. Heat capacity depends on mass and material type both, but specific heat capacity only depend on material type or substance type. Specific heat capacity only depend on substance type. Substance type. Hi. Today we discussed very sensitive and important points. Please go through again them, and again I balala you have to practice. Okay, next we have mathematics section. Question number 5. Okay. Okay, I typed Mansi. Okay, we discussed very important points of heat lesson today. We have to go through again. Do you need break? Okay. Okay, let's try to complete this question, and within we have 25 minutes. Hi. The floor plan of an equilateral hexagon shape, all fourth, is shown in the figure 1. The center of the floor is O, and the side of length is 60 meters. The main entrance of the fort is the AB wall, and the shape of it is depends in the figure 2. Yeah, AB has a figure 2, it's a main door depicted in figure 2. So not depend. The entrance. There are 6 similar towers in A, B, C, D, E, and F corners, and the shape of a tower is shown in the figure 3. Consider phi equal 3.14, root 26 5.01, and root 3 1.73 in calculations. And sine cos tan values are given. Right. Question number 1. Using the data given in the table, using the given data in figures, calculate the length of FO. Calculate the length of FO. This length asking. Actually, we in 2015 question, as I remember, we discussed same type hexagon question. Now it's a equilateral hexagon. Equilateral hexagon, always it is, these triangles are equilateral triangles. 60 meters, 60 meters, 60 meters. Previously we discussed. Then answer 60 meters. 60 meters. Because equilateral hexagon. That's the reason. 60 meters within bracket equilateral hexagon. Equilateral hexagon. Area of the base of the tower. Area of the base of the tower means this hexagon area, right? Hexagon area. Now, you know, if it is equilateral triangle, this side, this angle 60. This angle 60. Now, we can get hexagon area equal triangle area multiplied by 6. Triangle area half AB sine C. Half AB sine C. Hexagon area or base area triangle area multiplied by 6. AB sine C, half AB sine C into 6. Make a cancel into 3. Now A 60, B 60, sine 60 into 3. 60 into 60 into sine 60 root 3 over 2 into 3. It's 30. Nine into 6, 54 root 3. Now root 3 value is given 54 multiplied by 1.73. 53 value 1.73. Get this answer. Sorry, root 3 value given, it is 1.73. Can you send me answer? Sarmya, what's the answer? What's the answer? 54 into 1.73. Joel? 90. 54, right? Because sorry. My bad, my bad. It's 16 to 16. Sorry, 10 there. Yeah. Root 3. Because 16 to 30. I have multiplied only 6 into 3 into 3. Yes. I forgot these 2 zeros. Yes. 5,400 into 1.73. You are now correct, right? 9,342 square centimeter. No, square meter. Square meter. Sorry, now correct. Area done. Flow area of the section of ABCF. 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 That means half. Half. Sorry. In the question number 2, the area of the tower is asking. Tower, according to question, this is the tower. This is the tower. Figure 3. Tower. It is not the tower. Miyatama tower. Sorry. Second part wrong. This is tower. Now tower diameter is given 2 meters, the radius only 1 meters. Make a second part answer. Second part answer, it's only 5r squared. 5r squared. Area equal 5r squared. 5 value given 3.14 multiplied by r squared 1 into 1. 3.14 square meter. That's the second part answer, not the previous one. Tower area is asked. The figure 1 make a tower. Floor, in the third part asking the floor area of section ABCF. ABCF mean only 3 triangles are now correct. One triangle ABCF area. ABCF area, this is a third part answer, not second. ABCF area, one triangle area multiplied by 3. And then it is 3. One triangle area multiplied by 3. Half into 60 into 60. Sin 60 means root 3 over 2 into 3 now. It's 30. Again 30. 3 into 3, 9. 9 into 3, 27. 3, 2 zeros, root 3. You can get the answer. The ABCF area. $1.73. 4,671. Square meter. This is the third part answer. Not second, third part answer. In second one, ask the base, tower base area. Fourth one, the area of the inner floor of the fort. The area of the inner floor of the fort. Now asking the full hexagon area, inner floor. This is a full. Okay, no need to calculate again. The previous answer, fourth part. Previous answer, 4,621 multiplied by 2. Don't take time. It's 9,000 value, no? 10% value. 2 into 1, 2, 4. 9,242 square meter. 9,242 square meters. Previous value multiplied by 2. That's the full floor area of the fort. Okay, next one, the part B. The door at the main entrance is made of 0.3 meter thick woods. 0.3 meter thick woods. 0.3 meter thick wood. The shape of the upper part of the door is semicircular as shown in the figure 2. See, it's a semicircular part. Now it's a semicircular part. Now it's a small cuboid and semicircular part with very small thickness, 0.3 meter thick wood. That means 30 centimeter. It's a considerable thickness, 30 centimeter thickness. Calculate the area of the front surface of the door. Very simple. Calculate the area of front surface of the door. Okay, how to calculate? B part 1. B part 1. Now, front surface, it's a rectangle. It's a rectangle shape. This one, rectangle. 5 into 2. Rectangle area. 5 into 2. It is 10 square meter. Now, semicircle area. Semicircle area. Semicircle area. How to get this semicircle area? Circle area divided by 2. Half pi r square. Half pi value 3.5. 3.14. 3.14 r squared. The diameter 2 meters, then radius 1. 1 into 1. 3.14 divided by 2. 3.14 divided by 2. Please send me quickly. $157, right? 157 mean 1.57. Correct? $1.57. Yes, square meters. Now total surface area, total 11.57 square meter. 11.57 square meter. 11.57, very simple question. 11.57 square meter. Okay, part B, part 2. The mass of the cubic meter of wood used to make the door is 100 kilogram. Calculate the mass of the door. The mass for cubic meter. It's a very good question. Now, how about the cross section area? 11.57, right? Yes, 11.57 square meter. 11.57 is a square meter. Now, for this door, for 1 cubic meter, 100 kilogram wood is required. 100 kilogram wood is required. Now, first of all, you can calculate the volume of this door. volume, it's a uniform thickness. It has a uniform thickness. Now it is uniform object. The cross section area multiplied by thickness. Cross section area multiplied by length or this thickness. The cross section area 11.57 square meter multiplied by 0.3 is the thickness, 30 centimeter. 0.3 meter is the thickness. Now, please can you send me value? 11.57 into 0.3. Quickly. 11.57 into 0.3. Anyone? 3.471. 3.471 cubic centimeter. Cubic centimeter. Cubic centimeter. Now, per 1 cubic centimeter, how many mass how many wood of mass required? 100. Then the mass wood requirement would required 3.471 347.1 kilogram required. Final answer. 347.1 kilogram of wood required. Because per 1 cubic meter, 100. Let's go to part C. If the tower given in the figures 3 consists of the cylindrical part and the right circular cone, calculate the surface area of the tower excluding the base. We can neglect the base. Okay. Cylinder area plus cone area. But cone area, we need slant height, no? It is 1 meter. The perpendicular height 5 meters. First of all, I need to calculate this L using Pythagoras theorem. L squared equal 5 squared plus 1 squared. Now L equal 25 plus 1 square root. L equal 26 square root. I got the L now. 26 square root. 26 square root already given, then you can happy. You are correct. 26 square root already given, 5.01. 5.01. 5.01. 5.01 meters. Then හැදුවා වගේ තමයි. 5.01. Okay, I'm going to erase this step. I got the slant height first. After that, now I can get the total area of tower. Area of tower. Total area of tower. What's the equation? The cylinder outer area 2 pi r h. Matakai the equation 2 pi r h plus cone outer area phi r L. 2 into phi equal 3.14, radius 1, h 10. මෙන්න cylinder. 5 3.14, radius 1, L 5.01. 5.01. I will erase this one. 5.01. Now you can get the answer. Very simple. $31.4 into 2, 62.8. 62.8. I want this multiplication. 3.14 into 5.01. Tanya? 3.14 into 5.01. 15.73. 15.73. Okay, now you can add these two values. That's the total surface area without bases. 3, 8, 6, 7. Square meter. Note down clearly. Okay, no need to note down. If you're not complete, you have to make calculate again, because they are very simple questions, exam question. Obtain the tangent value of the angle of elevation to the top of the tower located at F as seen by a child at the position O. It's a good question. Obtain the tangent value of the angle of elevation to the top of the tower located at the position F. Position F as seen by a child at the position O, whose eye level is 1 meter above the ground. Hi. Now the tower is F. Tower is on the F. This is a tower. This is a tower. This is a tower. This is a tower. Now the boy is locate O at the O point. O point. This is a boy. This is a boy. This is the height. He has 1 meter height up to eye level. 1 meter height up to eye level. The question asks the angle of elevation. The angle of elevation. This angle. Theta. Theta. Okay. Now you can get the total height of the tower is 15 meters, but due to this eye level, it is only 14 meters. 14 meters, right? 14 meters. Very simple again. Now the adjacent 60. In first part you got. Then tangent angle. What's the tangent? Tan theta equal opposite over adjacent. 14 over 16. 14 over 16. 14 over 60. Sorry, 60. Yeah, 60. 14 over 60. I'll erase this. Tan theta equal 14/60. Now T tan inverse 14/60. Again, read the question. Obtain the tangent value of an angle of elevation to the top of the tower located at the position F, Hari, as seen by a child at a point O, whose the eye level 1 meter above the ground. Yes, correct. Now you can get the angle using calculator. 14/60. Tan inverse 14/60 value, because I don't have scientific. Yeah, approximately it is 13 degrees, right? 13 degrees. Hard. Okay, that's the end of refresh paper number 5. Okay, and next week I hope to discuss about mainly thermal transformation questions and thermal transformation rate questions. Therefore, don't miss these special classes. Nowadays we are discussing in a final 4 months and next week final 3 months. Therefore, don't miss anything. Now we are doing very important things always. Do you have any doubt today? Today discussions? Sunday. What's the best time for our Sunday class? Or can you do it every Friday? Because Sunday evening I have a special work. I free on Friday. We need only now, this time we are doing approximate 3 hours. 3 hours or 2.5 hours. We need another 2 hours on another day. Friday, okay? Let's do this Friday. And next, tomorrow we are doing the, you need the homework. No, I'll send you today the data set and practice and develop this last equation, last group frequency distribution, and come to tomorrow class. Tomorrow we discussed how to analyze group frequency distribution tables questions. Then analysis part complete within 1 day. Let's complete interpreting part. Then statistic complete. Next start our chemistry lessons, industry chemistry and natural products, and fluid mechanism. The syllabus will be covered. Okay, that's all. Good night. Goodbye.